All right. Well, thank you so much to Sarah and Rod and all the other GI staff who always do such an incredible job at promoting our work and putting these events together. I really appreciate everyone that's come in tonight. If you're not in Fairbanks, it's Snowmageddon out there. And for someone that loves the winter, not feeling so good about it right now. So I think we're all a little tired of all the snow, but thank you for coming in for this. So, we're really excited to talk to you tonight about this exciting journey that we went on. I'm honored to be here with my colleagues to talk over our voyage across the Bering Sea. I want to start by thanking our supporters, both here at UAF and beyond, especially the National Science Foundation, who provided funding support. This is the National Science Foundation's Navigating the New Arctic program. So we want to give thanks to them. Really special thanks to the Geophysical Institute's director, Bob McCoy. Bob has been an early champion of the Alaska Coastal Cooperative and the Action Project. So thanks so much, Bob. And moving on, we're going to look at some introductory stuff here. And I want to say that we're 4 people, but we're actually representing 21 other people that were on this cruise, and all of them contributed immensely to the effort. And so we're going to tell you the story from our perspectives, and hopefully we'll do it all justice for all the other collaborators that were involved. Charla, who is way out in Gambell, which is on St. Lawrence Island, unfortunately, since Saturday, she's been trying to get in for this event. We were really excited to have her here, but flight canceled. And so she's on Zoom with us tonight. So we're going to start out with Charla introducing herself, and then the rest of us will do the same. Go ahead, Charla.
Hi, everyone. My name is Charla Kuzada from Gambell on St. Lawrence Island. I was born and raised here. With Siberian Yupik as my first language and English as my second language. I am also a proud mother of a United States Marine, and beyond that life where I serve our nation, I also serve as a secretary for the native village of Gambell, and I'm a principal investigator for the Action Project. So uh, uh, I serve from the sovereignty of our village to the defense of our nation and the future of our coastal science. Thank you.
Hello, everybody. My name is Shauna Byrne-Silver. So by training, I'm an environmental social scientist, and I'm also a professor at Arizona State University, where I live and work on the traditional lands of many Indigenous peoples, including the Akmiel O'odham and Peepash Maricopa Indian communities. I also want to say that I am more than just my science brain. I'm a mom of 4 foster kids, adoptive and biological, and I'm a long-term partner, sister, and a great auntie. So being an environmental social scientist, it means that I really think a lot about how people are connected to the places where they live, both landscapes and seascapes, and what those relationships really mean for people, for wildlife, and for places, and for non-human entities. I also think a lot about how collaboration happens and what are the ingredients of really strong and equitable collaborations between communities and researchers. By background, I'm originally from Colorado. My family came from the Midwest historically. I think a basic curiosity about how people interact with landscapes and why they make the decisions that they do, it drew me into the Peace Corps. I was a Peace Corps volunteer in Mali, West Africa. And from there, I pursued a master's in resource interpretation and eventually a PhD in human ecology, both at Colorado State University. there was a postdoc opportunity that jumped out at me when I finished my PhD, and it was up here at UAF working with Gary Kofinas and Terry Chapin. And that's what got me up here. Since then, I spend about a third of my life up here. I have a cabin, dry cabin up here in Fairbanks, and I spend summers and as much time as I can up here. The Arctic really grabbed hold and never let me go. If you're thinking, for my PhD, I worked in East and West Africa with pastoralists. And if you're thinking, wow, there's a big difference between the savannas and the Arctic, it's a place where people live at the extremes of climate. And so there's a lot of commonalities in how people interact with places around that idea. And I've been incredibly privileged to work with Alaska coastal and interior communities for a while now. And I'm continuously amazed by their knowledges, their cultural strengths, and real resilience in navigating just an incredible set of challenges and change.
Hi, everybody. I'm Kay McMonagle. I'm an assistant professor here at UAF, and I'm a physical oceanographer, meaning that I study the physics of the ocean. I grew up in Tacoma, Washington, which is pretty close to the SeaTac airport. And as a kid, I really loved going down to the beach. So we could walk a couple miles down a trail from my parents' house. And every holiday, and really most of the time when it wasn't raining, we would go head down to the beach. Also growing up, I was pretty good at math, and that seemed like something useful. So when I went off to undergrad, I decided to study math. And I didn't really see any connection between these two things until I went to a conference my last year of undergrad and stumbled into a talk on physical oceanography, which I would basically describe as using math to understand the ocean. And at that point, I decided that that's really what I wanted to do. And I continued on to do a PhD at University of Miami, where I was going out on research ships with South African scientists to better understand some of the currents around South Africa. And through that, we worked a lot on capacity building and international teamwork. In 2023, then, I moved up here to UAF, and I've really enjoyed learning a lot more about the ocean around Alaska and getting to know great colleagues here.
Yeah, my name is Chris Mayo. I'm originally from Massachusetts, and I grew up on the beaches of Cape Cod. From an early trip I took with my dad sailing around Cape Cod on a little 23-foot Marshall catboat, I've always been drawn to the sea and adventure. And so that brought me hitchhiking to Alaska in 1996, came up here to get rich fishing and never did get rich, but I made it up here, built a cabin and started a family in Homer, lived there for a decade before I realized, maybe I should study science. And went back east to UMass Boston and Woods Hole Oceanographic to get my master's and PhD in environmental science. So looking to get back to Alaska after that, I came up here in 2014 and started working here at the university. And since then, I've been working in rural coastal communities with my graduate students and undergrad students, studying coastal hazards and engaging with Indigenous folks out there and trying to really grapple with some of the challenges that are being faced today. So currently I'm a professor in the geoscience department and a director of the Arctic Coastal Geoscience Lab and the Alaska Coastal Cooperative. Before I start out, I do want to just say that we're honored to be part of this Science for Alaska series. We've had such an awesome run this winter so far. We had Roos Bay and Martin taking us on a journey of climate science and hyperspectral remote sensing. We had Carl take us on an adventure to solve the 1912 earthquake mystery. And then last week we went to Greenland with Martin and Amy to learn about their exciting glacier work. So this really shows the breadth of what we have tonight. And so we're going to move into the grand finale of this season's talks. So this concept of the Convergence Research Cruise came to me when I was actually out at sea on aboard the Sikuliaq on another cruise. So I had I had the ability to run these ideas past the captain and crew, and it was pretty clear from the start that this was a pretty outside the box idea. You know, I wanted to bring a group of interdisciplinary scientists, Indigenous scientists and knowledge holders from rural communities, a filmmaker, and others. And then I wanted to take the ship and I wanted to not do research offshore that much, but actually bring the ship into communities and focus the research there, and also do a lot of public engagement. And so in the past, Sikuliaq had been to one community for 5 or 6 hours, Little Diomede. And so we were saying we want to bring this ship in for 2 days into each community. So it was very unprecedented. The variety of research we were posing is also pretty unprecedented. So with that, you know, the idea, we wondered, you know, will this grand experiment work? And it really was an experiment. We really could have descended into chaos at any time. And I wondered when I was going to get mutinied against, and I'd be put off in St. Matthew's Island or something. But you know, it attests that everyone that went on the cruise is better friends now than when we left. And I think that attests to like how well it worked. It actually was incredibly successful. So tonight we're going to take you through the story of our voyage. We're going to start giving you a little background on kind of why we did it, a little background on our project. Then we'll get into the process of how we did it. And then we'll kind of close out with a series of outcomes from our process. And then we'll hopefully leave plenty of time for your questions and discussion. So first, the why. So as many folks know, you know, rural coastal communities in Alaska are on the front lines of a rapidly changing Arctic. And despite their resilience and their strength towards these challenges, it's still the fact that their communities, their infrastructure, their culture, and their ability to develop their economies is still threatened. And so this requires new approaches to try to tackle this issue. You know, on top of this, we have that academic scientists traditionally have gone into silos to study this work. And therefore, we're not really practicing that convergence, that collaboration as well as we could be. And oftentimes the research that's being done in communities is not always benefiting communities. So we're trying to flip the script on all of that. And so with these complex challenges, it's really thinking about strengthening and scaling up the approaches that are working, because there is some existing work that's wonderful, and then also developing new approaches to collaboration. And that's one of the things we're going to talk about tonight.
Hey, we usually don't get any typhoons up here in Alaska. They usually die down when they're up on their way because of our cold weather. But lately, our weather and temperature has been warm, so they've been hitting our coasts. And the Burbach that hit in 2022, we learned that our infrastructure was at risk, and it proved that we needed more than just snippets of weather data. We needed real-time monitoring and indigenous-led protection. So, and the Halong over here, it didn't hit our island, but it did hit near, straight across from our island where Kipnuk is. It was a wake-up call. And our erosion, there our natural seawall, when the land freezes, we start getting cold in early September. And the fall time waves, when they hit, it wouldn't cause an erosion because our land would be frozen. But since our temperatures are higher, the land doesn't freeze anymore. So our natural seawall isn't there anymore. So we've been seeing a lot of erosion from there. Thank you.
Yeah, so as Charlotte said, it was a wake-up call. How long was a wake-up call that these things that we were projecting out 10, 20 years from now are happening now. And so in 2023, the ACC's Action Project was funded to address some of these challenges by NSF. And our overall goal is really to contribute towards actionable science that's driven by community needs and priorities. And we do that through this 3-pillar mission. And our mission has really been, founded on a decade of listening and learning from rural Alaskans on what the priorities and what the needs are there. And so the idea of the 3 pillars is that all of our activities actually integrate these. And so the first one is strengthening communication. So this goes from building collaborations, but it goes past that to actually governance and understanding who the different players are, where the tensions are, where the relationships that are working and where are the ones that are not working, and how can we improve and enhance on that. The second pillar is advancing applied science. And so when I say applied science, I mean science that actually contributes tangible products to communities for decision-making and planning. So these are real products, mapping products, other things that they need to move forward with economic development and some of the other things they're looking to do. And then the third one is building technical capacity. And this is really the most universally accepted idea that we've developed is this. Everyone knows that the capacity at all levels is very low, both here at the university and in rural Alaska. And so we're trying to build that capacity through many different ways, everything from training local researchers to accurately collect data, to developing youth leadership opportunities, to doing a number of other things like bringing grad students out into rural Alaska so they're trained and gain experience in effectively working with those communities. Now, all of this is founded on co-production, and Shauna's going to get into that in just a minute. And the important thing to remember here is this forms the framework of our planning and carrying out the Convergence Cruise. So these are really the main themes that we tried to hit on the cruise.
And just a second back to that map. So there are 8 communities that really form the framework for action. So all the way from Tuktoyaktuk in Canada to Kali, Point Lay, Gambell, Sikuliaq, Hooper Bay, St. Paul, Atka, Nelson Lagoon, Chignik Intertribal Coalition, which is actually 4 communities together. And then there are 2 Alaska UAF rural campuses who are also partners. Okay, so Chris mentioned that the Action Project is framed around ideas of co-production, and he also mentioned the idea of convergence. So aspirationally, I will say that Action is trying to push forward on both of those things. Both speak to a process of bridging multiple kinds of knowledges in order to build something new that is a synthesis, but they are really different. So Action is an NSF-funded project funded through the Navigating the New Arctic funding call. There are actually 144 projects that were funded under this call. And all of them, in order to be funded, they had to make a pitch that they were really doing convergence. So what's convergence? Convergence is a process that intentionally convenes intellectually diverse researchers to develop effective ways of communicating across disciplines. And Chris mentioned the silos, so it's specifically trying to break those down. Then there is knowledge co-production. So this is an effort to grapple very actively and push back on histories of colonialism and extractive and inequitable research. And this is an approach that's being articulated by social scientists, but also by Indigenous thinkers themselves. This sort of extractive research has really characterized decades of interactions between Western scientists and Indigenous communities. And so knowledge co-production is a process of bringing together Indigenous people's knowledge systems and science to generate new knowledge and understandings of the world. So by action trying to bridge both of those things, what we're trying to do aspirationally is work across worldviews. I'll pass it over to you now, Charla.
When we talk about convergent science, most people focus on the idea of different scientific fields like engineering, biology, and computer science all working together to solve a big challenge, and that is absolutely right. But for me, as an Alaska Native person, true convergence means something much deeper. It is the necessary, intentional, and respectful merging of Western science with Indigenous knowledge and cultural values. It is about bringing two different ways of knowing the world into one shared space. Here in the picture, in the center, you could see George Apaticki on the ship's bridge teaching the captain and the first mate how to navigate the currents and the waters around Gambell. Thank you.
So in action, bringing together knowledge convergence and knowledge co-production means that we think about two kinds of outcomes in our work. First, strong, equitable processes themselves become outcomes. So methodologies and collaborations are outcomes in and of themselves. And secondly, we expect that these good processes put into place will yield and lead to new knowledge and innovation in the process of knowledge convergence itself. So be thinking about those two outcomes as we go forward. So here is all of the partners on action. And if you're looking at this and you think, wow, I can't make head nor tail of this, that's actually kind of the point here. There's a lot of complexity. We have 5 universities, 2 rural campuses, industry partners, agency partners, and 8 communities that we just talked about. And we are starting from existing collaborations where, for example, Chris has worked in the Southeast for a long time. I have worked with folks on St. Lawrence for a long time. We're building on those existing collaborations and we're expanding between communities. So when you look at these logos, don't think so much about the logos, think about the people who stand behind the logos and who, through a process of really getting to know each other, are really doing good work. And so we're an incredible group of leaders and doers.
So our goal was to put the pieces together to help convergence and co-production happen. And this was a really big challenge, and it required a major research infrastructure. So the Convergence Research Cruise was bringing the mission of action to sea to fulfill our goals and broaden our impact beyond just the kind of land-based components. We set sail on RV Sikuliaq, the only ice-capable U.S. academic research vessel, in July of 2025. And we traveled from Seward across the Gulf and then north through the Bering Sea, conducting research and community visits along the way. And what happened on our journey exceeded anyone's expectations because we had put in place what we knew were the pieces to allow co-production to happen.
Kind of the idea of how we built this, like literally what are the building blocks that we had to put in place in order for this experiment to take wings. It's really the how. So this is a 5-year project, 4 years with a year of extension possibility. We're at the beginning of year 3. The first year and a half really focused on a process of visioning. So this was an iterative set of interactions and visits and communication and co-production of research planning for all 8 of action communities. What emerged from that was a set of priorities. And every community is unique, but there were some shared elements that emerged quite strongly. So coastal erosion was one. Coastal flooding is another one. HABs harmful algal blooms was one. Training was another one. Missing data was another one. But there were some emergent ideas that we really had not expected and were not in the original proposal. One of that was engagement with youth. This is something that communities were just emphasizing over and over again. Engagement with language, so language revitalization. And it really harks back to what Charlotte was speaking of when you're talking about culture and identity and place-based relationships as a whole, not just the science, not just the one thing. So from that, our task was to take this set of priorities and to translate it into a set of things that we could do on Sikuliaq. And so how is it that we could pull together the right community partners? How is it we could incorporate language and youth voices and the importance of foodways and underwater topography and sediment coring and wave buoys and ocean moorings and harmful algal blooms? So it was, how do we take these priorities and translate it into community-driven priorities in science on Sikuliaq? Of course, the next piece is to really think about who is the crew. So the goal was to pull together a really dynamic and diverse group of folks. And so what you see here is all the different places that people came from before they got on board the Sikuliaq. And I've got them color-coded based on kind of the types of knowledges that they are representing. So we have social scientists in green, physical scientists, physical oceanographers in red. And in the blue squares are Indigenous knowledge holders and Indigenous scientists themselves. So Indigenous folks came from Utqiagvik, from Sikuliaq, from St. Paul, from Atka, from Unalaska, from Nelson Lagoon, and from Chignik Bay. You can see folks came from downstates. I'm one of those. I'm a social scientist. And the yellow dot all the way in Washington, D.C. is an NSF program officer, Colleen Strawhacker, who was actually on board the ship with us. I mean, how amazing is that, that she was able to be on board Sikuliaq for the 16 days. Also on board, so we had a crew of 21. Also on board, we had an evaluator from Goldstream Group here in Fairbanks, and her role is to really put us to the test, to literally see if we're putting our money where our mouth is, are we actually doing what we're setting out to do? And so she's watching and thinking along with us. We also had a storyteller and a filmmaker. So this is Ryan from Alaskanist Stories. He came from Anchorage, and he was on board with us. So this is day 15. We're dirty. We know each other really well. There's lots of smiles. You took strangers, for the most part, put them on a boat, and pressed the magic button. And what you got out at the end was a real crew who really knew each other quite well. And I want to shout out to Matthew Balazs, who's in the audience. He was on board with us, also from US, physical geographer. Okay.
So along our journey, we engaged in learning modules, and something really important in this is that we were all teachers and we were all learners. So the photo there is me teaching Shauna how to deploy a wave buoy, and on the next slide, I'll show a photo where Shauna is teaching governance. I'm not in the photo, but I was there learning from her. And we did this through really structured methods so that we made sure that there was time for the learning. So there's an example here of our daily schedule. We had some folks who were more kind of morning people. They got up, had breakfast, did cleaning and preparation for the day, and then they engaged in teaching and learning through these modules. Then in the green there is times that all of us were together. We would eat lunch, and we would do some module learning where it made sense to have the full group of everyone together. And then we would have some meetings where, again, it was intended for everyone to be getting the same information. And then in the evening, we had our more evening type people also doing cleaning and preparation and teaching and learning. And then we would start over the next day. And this is an example of what our schedule looked like when the ship was going in between communities. When we were in the area of a community, we also had science operations happening all night. And so there were people taking bathymetric surveys, mapping the seafloor, and doing other science ops. These were our 8 learning modules. I'm just going to quickly walk you through them. So starting in the upper left, we have JJ Orloff from Chignik Bay, and she is teaching Indigenous arts through teaching fur sewing, and we were making beaver headbands. Then moving to the right, Charla and Shauna are teaching us governance with an activity there to think about the different groups that are involved in governance. Moving to the right, then we have UAF postdoc Jessica De Paolis teaching us different types of plankton and which ones might be harmful and potentially cause a harmful algal bloom. And then on the upper right, we have an engineer from Sikuliaq teaching us about the ship systems. How does the ship keep running every day? Moving to the bottom row, our next module is braided surveying, and Chris will tell you more about that in just a minute. I taught a module on oceanography, so thinking about what do ocean currents look like, how do we measure them, why do we care? And then moving further to the right, we have Destiny Cushion, who is looking at a sediment core. So she learned about what sediment coring was, then actually went out on the deck and helped take a sediment core. And then here she's describing the sediment core as far as what it looks like so that into the future we have notes from that. And then the final learning module was foodways. And this is thinking about the cultural and social and political side of food preparation, eating foods, all of that. So thinking about things like hunting and fishing and the cultural impact of food. So that goes back to some of what Charla has shared as well.
Great, and you can see from all those modules that we were very busy out there. So I wanted to give one of the examples, the braided surveying is just a great example of one of the modules because it perfectly integrates our 3 pillars. It brings together the communication, the applied science, and the training and workforce development. This module was developed by Matthew Balaj and here in the GI, remote sensing faculty, and also Morgan Berthusen from McGill. She's a PhD candidate there in Canada. And so this module integrates the physical and social science with the Indigenous knowledge with the overall aim of really developing opportunities for actionable science and the co-production of knowledge in the 3 communities where we went ashore. And you can see in this picture here, I love this picture because it really captures this co-production stuff. You have Matthew here from the GI. You have Alex, an Indigenous scientist and leader from Atka. You have Morgan, a social scientist from Canada. Kayla over on the right, originally from Unalaska, undergrad at University of Hawaii, now a grad student. And then you can just see the tattooed head there of Kayan Harsharak, who is an Indigenous scientist and a renowned whale hunter from Utqiagvik. So this amazing team is in their prep for planning out the Atka surveys. And so to kind of walk you through the methods of this, first, before we arrived in the community, there was a lot of discussions, looking over maps, understanding both the physical components of the landscape and also the priorities that the local tribe is wanting us to carry out. And we're not only getting kind of that geography component, but we're also getting the historical and cultural context of these locations. So that's really important. And then when we're actually in Atka, we're going ashore, we're conducting the research in Atka. They were really concerned about some erosion taking place near an old military dump site, as well as soil and water testing in some contaminated areas. And so this is the work we did, but it wasn't just the physical science there. When we were there, we were getting locals to join us, our partners there, to kind of identify what this place means, what's the context of this specific location. Having those local partners also allows us really specific information of where to survey, what are they most concerned with, not just this general area, but specific location. So that's really key, that collaborative aspect of it. And then once the surveys were done, we would come back to the ship, we'd head out to sea, and then we'd kind of debrief and go through that whole process, evaluate it, talk it through, and then look over some of the data products.
Okay, so now what we're going to do is take you through kind of two ways that we were thinking about convergence and co-production. And the first one of these is to talk about Gambell as the third of 3 stops. I do want to contextualize. So we stopped in 3 communities. Chignik Bay was the first, Atka was the second, and Sikuliaq was the third. There were 2 elements, 2 big kind of categorical elements to it, which you've gotten a sense from listening to Chris just speak. The first is ship and shoreside research, and that what occurred is based on community priorities and that braided survey, the planning, the pre-planning. And then once we're there, it was this full court press to connect with folks. And this is really interesting because, I mean, within Action, we meet weekly. There are working groups that meet sometimes twice a week, but community to community learning where folks from other communities actually got to Atka for the first time so that Alex could say, when I talk about erosion, this is what I'm talking about. When I talk about loss of dunes, this is what it looks like here in Atka. And folks who were from Nelson Lagoon could say, well, this is what it means in Nelson Lagoon. So this community to community conversations once we were in communities was amazing. The other piece was so community folks and scientists. So that's another element of the communication. And also the Sikuliaq crew who had this opportunity to get off and talk about the science that's done on this amazing piece of infrastructure. So the connections happened at barbecues. It happened in the hunting and fishing that went on. It happened in the ship tours as people came on board, and it happened in Gambell and at Atka, which I'll talk more about in a second. And I really want to emphasize that this was a completely unprecedented engagement of Sikuliaq with communities. So focusing on Gambell, the 2 elements. So on the next 2 slides, I'll take you through the 2 elements. So shout out to Matthew here because a lot of this work, I'm going to focus on kind of the braided surveying process on the ship first. So in July of last year, there was a group of 10 of us who were in Gambell for that visioning process. So we met with the Tri-Org, which is city, tribal, and local corporation. And we really started that visioning process. As part of that visioning process, there was photogrammetric surveys and cross-shore profiles that Chris carried out with the community research leads. That led to conversations about what could we do when the Sikuliaq was in port. So that pre-planning process really identified that there were areas of the north and west beaches that were of the greatest concern for folks in terms of coastal erosion. So we focused on these 2 areas, producing data for floodplain mapping and potential use in evacuation planning, and also thinking about the shift in species, primarily crabbing that takes place off of the shore fast ice in the wintertime, and habitat that has really been shifting because of sediment transport based on fall storms. So based on those pre-planning conversations, I want to get this exactly right. So Matthew and Morgan worked with community research leads. You can see Daniel Apasanguk and Dana James in these pictures, both at the top right and in the boat. So they're community research leads who work 20 hours a week and on call on research in Gambell. So Morgan and Matthew, they were doing aerial LiDAR, and this is the highest resolution elevation data ever collected in Gambell and will feed directly into the stored and surge modeling that Chris is going to talk about in just a minute. So in addition to needing the topography on land, in order to think about flood risk, we really needed to understand the topography under the ocean. And that was done in 2 ways. So you can see this bottom left picture. This is Morgan and Matthew with Daniel and James. And so they identified areas where both the flooding risk and the sediment transport was of greatest concern. And based on iterative conversations during the day, they actually added areas that weren't really on folks' minds. So you can see that on the bottom right picture, they actually added nearshore bathymetry based on those conversations about flooding risk at Lake Nuyavak. So I'm not a physical scientist, but I really want to make sure that I get this correct. So that was a late add to the survey, but the second piece was what was done overnight, and that was the farther offshore, using a multi-beam survey that was on Sikuliaq. So that's going to contribute to a seamless topobathymetric model that will support community decision-making and planning around flood risk. So I really want to emphasize that it was an iterative conversation between community priorities and capabilities on the Sikuliaq that drove what was done in Gambell. Charlotte, take it away.
When we got to Gambell, it was a very nice day, but Gambell was the only village that didn't have a dock. So there were 44 trips that brought scientists, the crew, all on these small little boats on the far right. They went back and forth 44 times, and a total of 21 visits. You could see in the middle right there, Gary, who was in the council member with his daughter, and Jeremiah, who works at the native store with his daughter. They went on the trip out to the ship to see how science is done on there. And we also went hunting on a boat. There was a group of Indigenous Alaskan natives from 5 different communities that collaborated on a traditional boat hunt on the Bering Sea, launched from Gambell. We also had a barbecue. Chris cooked hundreds and hundreds of hot dogs and burgers for the whole community. And during that time, we had Eskimo singing and dancing, which we call atuk. It was very fun for the crew members and the scientists on board. So the first mate and the captain gave us an extra hour to stay in Gambell. And the last picture here is Shauna, who was the first one off in Gambell. She was at the beach the entire day.
I got really sunburned.
She survived off of Chris's chocolate there.
I had a bottle of water and a bag of candy, and I'm not kidding. Like, that's how I survived.
Yeah, and the ship also anchored there because it was so nice, about a mile out on the north side of Gambell. It was a pretty nice day. And mm, that's about it. That was a really fun day. Thank you.
The second story of convergence and co-production that we want to share about is about the oceanographic research that took place on the cruise. So first I want to highlight one of our operations, which was to deploy a couple of ocean moorings in the northern Bering Sea. And there were multiple reasons for this, but the first one was that this really addressed some of the needs of the local communities. So when they're thinking about storm surge modeling and what the future looks like, we really need to have a knowledge of the oceanography in the area, get a sense of what it looks like now. And also, this is a regional data gap that multiple agencies had identified. So groups like NOAA had pointed out, we really don't have enough observations here. And so to address both of these needs, we deployed 2 ocean moorings. and they measure ocean currents and waves, as well as temperature and salinity. They're sitting on the seafloor in the northern Bering Sea right now, hopefully collecting great data. We don't get the data back until we get them back, so I can't show you any data, but we should have some really amazing data that will have multi-stakeholder benefits when we go back and pick them up this summer. And we deployed one of those offshore of Gambell and one offshore of Hooper Bay, again, both to fill this regional gap, but also for our community partners. Another component that's already been mentioned that came up in a lot of the conversations with communities was harmful algal bloom monitoring. So harmful algal blooms have been a problem in parts of Alaska for many years, for instance, in Southeast Alaska, but further north in the Bering Sea, these weren't really that much of a problem until the ocean is now warming, and that's leading to more blooms. And so in this area, the species that's most concerning is Alexandrium cantonella, that's shown on the bottom left there. And to address this kind of concern from community partners, we were able to get an imaging flow cytobot, which is a water sampler installed on Sikuliaq. So this was something that is from the Alaska Ocean Observing System. And what it does is it sucks in a little bit of water as the ship is going along, and then it takes images of all the plankton in that water. And then those images get put on a website, and there were scientists from Woods Hole Oceanographic Institution that were monitoring those to see if we were in anything that looked like a harmful algal bloom. And when we went past St. Paul, we started to get images that looked like this. The images outlined in yellow there are Alexandrium cantonella. This is that harmful algal bloom species. It's really concerning because it can produce saxitoxin, which can lead to paralytic shellfish poisoning in humans and in other creatures. So once this was seen, then we were able to notify people in the area that there was likely a harmful algal bloom going on. We also stopped the ship and took additional water samples, which we sent to researchers at Woods Hole Oceanographic Institution. And we took some samples of the sediment to look at the Alexandrium cysts there. This species has a cyst phase where it basically lies dormant until the ocean gets warm enough, and then it can germinate and form a bloom. And so understanding where the cysts are is one way of informing people of kind of the risk of future blooms in the area. And this was in late July of 2025 that we came across this bloom. About a month later, there were 21 dead northern fur seals that washed up on St. George Island pretty nearby. And samples from those seals have now been processed by the NOAA Northwest Fisheries Science Center. And those seals did have saxitoxin. It was some of the highest concentrations ever seen in those species. So it's likely that that was coming directly from this bloom that we went across. I'll let this video play. Another community need was the need for real-time data. So that's Charla tossing a wave buoy off into the ocean offshore of Gambell. So I mentioned those ocean moorings, which are great, but we don't get the data back for a year. So a lot of our community partners were saying, you know, we want to know what the ocean's like right now so we can decide if it's a good day to go out. You know, we can't wait a year for our data. And so these wave buoys fill that data gap because they sit at the surface of the ocean. They can send their data via satellite, and you can pull it up on an app and know what the ocean conditions are like basically in real time. These measure waves, sea surface temperature, winds, and barometric pressure, and we deployed them at those yellow spots on the map. And you can see a photo there with Nanook, our mascot, on a wave buoy as well. And so these have been collecting data. This is data from those wave buoys during the time period of Typhoon Halong. And you can see in the yellow there the data from the buoy near St. Paul Island, where waves higher than 5 meters or 16 feet were recorded. And this is something that UAF PhD student Jackie Bite is digging into more detail to understand the impacts of this typhoon and what this means as we think about storms into the future.
Yeah, and so we mentioned already how bathymetric data is one of those key gaps that communities identified, as well as regional agencies. And so that was one of our goals out there, is to collect a lot of this. And you can see this map. So the Sikuliaq is just amazing for mapping the seafloor. Their data guru is Steve Roberts, who created this GIS that has all of the bathymetric data that's available for this region. And you can see the white areas are actually where the data gaps are. And from our red cruise track there, you can see we went through a lot of these gaps. So we were able to fill not just the areas directly around the community, which we really focused on, but also other areas across the Bering Sea. And the system on the Sikuliaq includes 2 different multi-beam systems and a topaz subfloor monitoring system, which we're able to actually look down into the seafloor and see the framework geology. So really incredible stuff. Up on the right there, you'll see the ship track where we spent about 2 nights through the night mapping that seafloor around Gambell. And that's how it would be. We'd do our stuff in the community, and then we'd spend all night cruising around with the ship and collecting this data. And the bathymetric data, the topographic data we talked about, that topobathy model, as well as the wave buoy data is being fed into, well, first it's being processed by UAF grad students, which is great. And then it's going to be integrated in these scenario-based storm surge models. And this is part of a collaboration with the USGS and Deltares USA. Deltares is one of the world-renowned modeling companies based in the Netherlands. So we're excited to have them on the project. And these models bring in different scenarios. You know, let's say we have Halong, but on a different storm track. We have a certain level of sea level, and we can enter all that information into the model. And then it kicks out these wonderful products that are really important for communities. So we have products that will identify areas that need mitigation immediately, areas that we can safely build infrastructure, and lots of other avenues to pursue there, all kind of directly feeding into that planning and decision-making work.
So now we're going to move into the part of the presentation where we want to focus on those outcomes. So we're going to link them directly to the 3 kind of pillars, which is communication, applied science, and building capacity. But think also about the process as outcome that I started with, and also then thinking about other kinds of new knowledge that we build. So I said that we were aspiring to do knowledge convergence and knowledge co-production. And it's an interesting question to ask. How do we know whether or not we kind of hit that target, whether we are doing what we say we're doing? And there's a lot of social scientists, actually, and a lot of Indigenous thinkers who are asking this question and writing about it and thinking about it and really pushing the boundary here. So how do we know that the connections that we made and the trust that we've built over the last 2 years and we continue to build, and the collaborations that we've put in place between folks that don't necessarily work with each other and the community research leads in communities, how do we know that that good process is translating into what we expect and what we're hoping for? So on this trip, we have a very strong sense that it did. And there are many small moments that I would point to as indicative that it did. But there is one night that I also think it really looms large in probably many of our memories. It was a night when we were leaving Atka, and there had been a reindeer hunt that day. So there were hunters from 3 communities, all the way from the very far north, all the way to the south, who were comparing how to cut a caribou based on how they were taught by their grandparents. There were folks who were standing around and learning how to cut a caribou for the very first time. You can see in the back the gravity core. Sorry, I'm still going to get it wrong. Multi-core. Sorry, I always confuse it when I was on the ship. So the multi-core is literally just being prepped to send down. And there was a group that was already looking at sediment cores that had come up. There was a group behind us which was working on fish that had been caught that day, and also talking about how to process it. And then there was Ryan, who was the filmmaker, who was literally like a hummingbird who was trying to get up high enough so he could capture this moment where it seemed like knowledge convergence was taking place no matter where you looked on the ship. So it's one moment that I look back, but I think if you asked anybody, there were these kind of big and small moments that really are cumulative in the process of both convergence and knowledge co-production. And so our task, and the task in front of us, is to scale this up. How do we do it in the last years of action, and how do we take the learning from the Convergence Cruise and talk about it more broadly, and incorporate it with the really innovative work that's also being pushed by others in this sphere? Charla.
Strengthening communication. I've learned on this, there are many, not many, but are different ways, but same thing, and we exchange all the knowledge, which are all important. We learned from each other and shared each other's ways, and they were all important. Also I'm sorry, hold on. And the knowledge which we all survived for thousands of years, we exchanged it all, and they were all important, and we learned from each other, and we're keeping all that knowledge. Thank you.
And this is one of my favorite pictures of the cruise. It really emphasizes this communication side of things. So here we have 3 generations of our collaborators in Chignik Bay, and they are on the ship for the day to learn about the research we're doing, to learn about the ship itself, and to have lunch in the galley. It's a really incredible day there. And you can see the captain in blue there, Captain Christoph, just having a wonderful time showing off the amazing Sikuliaq and all it's doing there. And I think this is really bringing the ship there more than even the research. It was that relationship building, that sign of respect that we showed the community. We said, you're important. We brought a world-class research ship here to study the things that you prioritized. And I think that's just a really key part that's going to solidify that relationship for decades. And as far as applied science, you've heard a lot about all the different things that we've done. One of the key examples that we like to use to kind of show this convergence and how it all came together is the installation of this tide station out in Gambell. And so this came about, it almost didn't come about. After Typhoon Merbok, there was a lot of money in the state going around to install tide gauges in communities that were impacted. In Gambell, there was some miscommunication between the funding agencies and the contractors, and some distrust grew from that. And it almost ended up being that this gauge was going to be installed in another community. And so when we went there on the port call, we really, talked to the leaders. We invited them on the ship. We had our barbecue. And I tell you, there's no way better than building trust than to show up with a 261-foot icebreaker and, welcome the people onto the ship to tour privately with the captain. Really incredible gesture that we made. And so that really alleviated that kind of emerging relationship, alleviated this distrust. We were able to move forward, and that gauge was installed in October. And it's what everyone that was involved wanted, the same thing. We just needed to kind of lubricate the wheels of communication. And this was installed, and when it was installed, our 2 community research leads there assisted with that and were trained how to maintain the unit. We also had Mike Willis, who now works for JOA Surveys, who did the install. He was a graduate student from UAF there, helping with this. And so that's the perfect symbol of how this project works. And now the data is up and available on Alaska Water Level Watch. And so again, we had our communication key pillar brought together through our work in Gambell there. We had the applied science. We have a tide gauge that's operating. It's going to benefit not just the community, but many other folks. And then we had the building capacity, both with our local research leads, but also with a UAF graduate student. Okay, Charlie.
Through action, I have learned that tribal leadership is the link between science and survival. The vision and the precision and discipline of our people, all working to ensure that Sikuliaq isn't just studied, but strengthened. And I also would like to I'm thankful for the survey in the water and the land in Sikuliaq, which hasn't been done since the 60s or 70s. We're kind of far back from the rest of the world, and we thank action for letting us catch up with everyone else in the world. And I like that really much. Thank you.
I want to emphasize here too that the learning always went both ways. Charlotte has been an incredible leader of the work that's been done and connecting us with others, but also we are learning from them just how complex the governance situation is in navigating the kinds of changes that you've been talking about. So navigating through multi-level governance regionally, state, federally is no joke. And so understanding that complexity through these relationships is really part of that two-way learning as communities are really trying to elevate their voices to navigate through these things.
Another example of the capacity building was a student experience and training on the ship. So we had a number of students involved. We had a couple of grad students at UAF, also a couple of UAF undergrads, and then a few students from other institutions as well. And they were trained in physical science techniques, but also engaged in all of these modules and learned governance, learned about foodways, learned how to engage with local communities. And so this is a part of building capacity and building leaders for tomorrow. None of this would have been possible without Sikuliaq as a major research infrastructure that allowed us to learn from each other and to conduct research. And also, it wouldn't have been possible without the crew of Sikuliaq. So everyone from the captain, the mates, the engineers, and all the other crew were with us every step of the way. They engaged in a variety of ways. They taught us about ship operations. They engaged in convergent research, and they joined us in community activities. And especially that part is something that's pretty rare. They don't usually get to go to shore and actually meet people in the communities that they're sailing by. And I think that that was something that they really enjoyed and that many people learned from and gained a new perspective as well. And so we really just want to say thank you to Sikuliaq. It's an amazing research vessel operated by UAF College of Fisheries and Ocean Sciences. And it was the perfect platform for us to do this work.
Great. And just a quick shout out for everything that is next. We have a snow machine trip going from Bethel to Sikuliaq coming up, Coast X, and we have Arctic Action coming up. You could follow us on Facebook to get all the updates on these next adventures. And with that, we thank you and we'll take your questions.
All right, any questions from the room for our presenters?
Okay, so it seemed like the the main point of the talk, a lot of it was about communication and building trust. And you mentioned the importance of knowledge going both ways, okay? So if this is a microcosm of the country as a whole, so we have some people who say that climate change is a hoax and they're banning the language. Do you have any lessons from this mission which could help in communication with the population as a whole or on a larger scale?
Yeah, that's a great question. Yeah, I mean, I think what this cruise really taught us, especially the folks that were out there participating, is we all had these very diverse backgrounds, you know, from being a professor like myself to being someone that's never been out of a village, you know, in nearly their whole life. So I think it showed us that, you know, we're all people, right? We all have very different backgrounds. We had whalers that grew up whaling, and then we had folks like me that grew up, you know, in Boston. So it's these different, we have these different mindsets, different knowledge systems, but through the process of engaging and building trust, we were all able to communicate. We were all able to identify shared goals and act on them. And so I think in our society as a whole, we certainly have opportunities to just treat each other like human beings, like people, and open up to actually identifying those shared goals and working together to achieve them. How's that?
I think it's also really interesting to think about how you frame conversations about change. So you can say climate change, and I would as a scientist, that's what I would say. But that's not necessarily how other folks in communities necessarily talk about it. They can talk about environmental changes that are dramatically affecting the way that they live their lives. And then while we were on the ship, we had kind of moment to moment, there were 3 people who were posting. And they were posting really what their observations were and what their takeaways were. And those posts were incredibly meaningful. I wish that we had a bigger platform because the conversations that were happening were not political, but they really were kind of this person to person, person to place, observational, and that was really powerful. So if we can figure out a way to sidestep maybe some of the really tricky language and focus on what it is that's meaningfully changing, observations from people who can really speak from the heart. Like, what does it mean to live on a flat place and watch how long come and wonder which direction how long is going to go? I mean, we were in Anchorage with folks from Hooper Bay and folks from Gambell, and they literally were all waiting to see which direction how long was going to go. It didn't matter what side of the political spectrum you were on in those moments. It was literally a decision point and uncertainty and fear, and those conversations are really powerful.
How about some more questions? I think we've lost our entire Zoom audience. Is that right? All right, well, we got the in-house discussion here, which is great. No online competition, free to ask questions.
I guess one question I would have for the action team is, you mentioned 144 other groups or projects. Do you know who were part of this action project, or not action, sorry, the original NSF grant? Do you know if any of those projects had to do with the research vessel who also went out and interacted with communities like you all?
The answer is yes, but I don't know which ones specifically. But I know that Sikuliaq and Norseman 2 are highly scripted and highly busy. And I know that there were other NNA projects that were using ship time.
Just not not going into communities like we did. They were doing offshore research.
I had a question on the harmful algal blooms. It seemed like the equipment was maybe fairly sophisticated used on ship. Is there any way to visualize that and give more real-time feedback so that way you can see where algal blooms are happening real time and provide that feedback to the communities?
Yeah, that's a great question. So, I mean, it does work in real time. You can put this on any ship that has a seawater intake, which is not a small ask, I guess I would say, for a boat. But you can put it on other vessels potentially, and you can also moor them. So you can, put it like installed on a dock or something, just sucking in the water. The instrument itself is kind of expensive. I want to say it's about $150,000 plus. Then you have to install and maintain it and everything. But yeah, I mean, potentially, I think having more instruments like that out on more boats would be a great way to start to have a network of where harmful algal blooms are, where they're moving, what the hotspot regions are.
I can speak to this a little bit for the Bering Sea region. So there is AHAB, the Alaska Harmful Algal Bloom Network, which the director is Thomas Ferrugia. I think that's how you pronounce his name. He actually was part of the harmful algal bloom module. So we brought him in by Zoom, and he was part of the lectures, the learning module about HABs. So he is part of an effort with Cooperative and the Nome Eskimo community out of Nome to get microscopes into the hands of EPA funded, what's the position? IGAP individuals in communities, and train them up on how to identify the harmful algal bloom, the spores. And so this is an emerging effort to actually put that capacity at the community level so that there is more of a direct connection between observation and, I mean, boy, there are no better observers of sea life acting strangely or sea life on beaches than there are community folks. And so it's an effort to connect that incredibly powerful observing network in communities with this new capacity, and in combination with shipboard, this new technology. But people are really thinking about this because it's a missed capacity at this point. It's a real gap.
Okay, maybe one final question. Anyone in the room? If not, I think we're going to wrap it up. Thank you again to our presenters. Appreciate it.